Hello, welcome back to Informs What's Your Story. I'm the host, Kara Tucker. I'm the editor of ORMS Today and Analytics magazines at Informs. I am joined today by David Bernal Neira. He is an assistant professor in the Davidson School of Chemical Engineering at Purdue University. And David has been an Informs member since 2018.
That's right.
I didn't do the math, but it's pretty long.
It's been a few years. That's right.
We're happy to have you. Thank you so much for joining me. So, David, tell us what your New Year's resolution is.
Oh my. Well, 2025 was the International Year of Quantum, so that kept me pretty busy.
Yes.
So certainly this new year, the resolution is to hopefully get as many things done as we did last year. Maybe with a little bit more sleep. That'd be nice. But no, I'm looking forward to 2026. All the good things it's about to bring for us.
Great, with just a little extra sleep.
Oh yes, please.
Perfect.
Yeah.
If not, you have coffee, right?
Oh boy, don't get me started.
Yes. So you are early in your professional career, I'd say, right? Tell us why you decided to first pursue the degrees in chemical engineering and then ultimately finding a passion in quantum computing.
Oh, okay, sure. So my parents are pharmaceutical chemists, so chemistry runs strong in my family. I actually have three uncles who are chemical engineers as well, sort of influence in that way. I have to say my brother is an industrial engineer, so yeah, there is some hope.
Yeah.
When I decided to start my college career, I ran this through my family. They were like, yeah, chemical engineering is a good way of understanding how things are transformed. Like we start from raw materials, we end up with things that basically make our lives better. Yeah. That's basically our mission as chemical engineers, and I resonated with that. Now, needless to say, I had this hidden passion called physics, and so I started this double major without expecting that the physics major would take much longer than chemical engineering. So like my academic life was a little bit disorganized. In fact, I started my PhD in engineering before I even finished my undergrad in physics.
Wow.
That was kind of crazy.
Okay.
Yeah, I know. And in physics, I was doing astrophysics, which has not much to do with, we're thinking about big things.
Right.
When I started working in engineering, I thought, well, it was great as long as it lasted, but I will never use this physics degree again. Until during my PhD in engineering came this opportunity to start working with the NASA quantum AI team in quantum computing, right? I of course, as anybody doing studying physics, I had to do some quantum mechanics courses and everything, but then using that for solving problems, which would eventually align with this mission of let's make life better for everyone.
Right.
That completely changed the equation. I went back to my physics books, and that's how I started doing quantum computing.
Okay.
Yeah.
So that internship, which we will talk about in a minute, was that your first, besides the couple quantum classes that you had for your physics degree, was that really the first deep dive you got into that?
I would say so.
Yeah.
I would certainly say so. I remember my PhD advisor, who's actually an Informs fellow as well, Professor Ignacio Grossman, once came into my office and he was like, oh, I'm giving this talk about how is chemical engineering, OR, their intersection that we call process systems engineering going to look like in 40 years. And me being the physicist in the room, I was like, quantum computing. Of course, back then I knew nothing about it. But I suppose that this stuck on his mind. So whenever this opportunity came, he had to point at somebody that was doing that knew anything about it, and he assumed that I could be that person.
Yeah.
He was partly wrong. I didn't know anything about it, but I was motivated enough to catch up.
It.
Yeah,
that's
exactly.
Great. So you obviously have a multidisciplinary background. How's that shaped the way you approach problems? And what advice would you give to students who are considering crossing discipline boundaries?
Oh, it's certainly living at the interface of two fields. often feels weird, right? Because you might feel you don't belong to either, when in reality you belong to both. So it's extremely exciting to go to talks in, I don't know, in the American Physical Society or the American Institute of Chemical Engineers meeting, or here at Informs, and see similar things being called by different names. And then you're like, oh, wait a second, right? I've seen that in this other place. So it's extremely encouraging. Like there is more places to grab things from. So to me, that is very motivating. Each community has wonderful people. So that also kind of expands your network, right? You get to talk to more amazing folks.
Right. Thank you. So we're going to get back to your NASA internship, because it's very interesting. You interned and then became an associate scientist there, correct?
Yes.
So how long was that stint at NASA between the two?
This first internship, it was part of a program called the Feynman Quantum Academy. In fact, I was nominated to be part of this by another Informs fellow, Professor Sridhar Tayur, Carnegie Mellon. In the previous annual meeting, he gave a keynote about quantum and so forth. And he basically was the one that connected me with this team. So that was summer 2019.
Okay.
Needless to say, I loved it there.
Yeah.
I mean, the kind of problems we're dealing with were fascinating. I had a great time also because that team was incredibly inspiring. That summer was the summer of the quantum supremacy experiment, where Google, NASA, and Oak Ridge came up with the first demonstration of quantum machines doing something that would be completely impractical for classical machines. So I also suppose they liked me because once I graduated, I knew I wanted to go to academia. I actually applied for academic jobs, and I got this offer from Purdue. But I decided, well, actually Purdue, we negotiated to delay that start for 2 years.
Okay.
And that gave me the chance to go back to NASA.
Wow, okay.
Learn things well, like try to bring some of that quantum computing knowledge into what today is my research group at Purdue. So that's how things developed.
Okay. So what would you say, any habits or mindset that you had at NASA that enabled you to succeed there? And you said they liked you. There's got to be more than that. So
well, I think that that team was also very multidisciplinary, right? It was mainly made up of physicists and computer scientists. Okay. With me, there was only one other person that I would say was an operations research kind of person that led to very interesting conversations, right? Things that folks outside of the field of operations research might think that they are impossible to do, unthinkable, like this traveling salesman problem in 11 cities. They claim that was impossible, whereas like our field has been working and basically cracking these problems for 50 years or so. So it was a very interesting environment where I think I was bringing to that team some knowledge, thanks to OR, to be honest, that they didn't have.
Yeah.
So that's
an edge.
That's how it ended up playing really well.
Okay. And how would you describe the research organization, the real world research versus the academic research that you might be doing now?
Oh, I mean, it's certainly, there are differences, right? But the thing that I liked the most about my job at NASA was my interactions with interns, right? I mean, they all are superstars, right? All of them, one in OpenAI, the other one in Los Alamos National Lab. Like they are super successful. And reflecting upon that, I was like, oh my, well, there is much more of this at Purdue afterwards. Yeah. So at least I know you asked about research.
That's okay.
Sorry about that.
No,
but I think that the interaction with young researchers is the most exciting part of doing research. Like doing it on your own. Sure, you get some results. They are exciting on their own, getting to have somebody else walk that path with you, to me, was far more exciting.
That's great.
Yeah.
And that kind of combines, obviously, your love for teaching and academia, right? Even though it was in a real world organization.
I mean, universities are real organizations, regardless.
Applied research, I guess.
I also need to say that the research that we were doing at NASA, so I joined this quantum AI lab at NASA, and it was a small team. We were 18 people doing very exploratory research, right? I mean, if you think about like, why would NASA care about quantum computing, right? Aren't they all about rockets and so forth? And yes, they are, right? Their mission is to support air and space exploration. We were kind of this pathfinder group trying to realize whether these new kind of computers were going to be, if anything, useful for air and space exploration. I learned a few things. Among them, there's this kind of mission was immediately translated to what I do nowadays. I tried to study these quantum computers and see how can they be useful for optimization and for chemical engineering. So I think that there is a lot to learn from how research is being done at these institutions, national labs, NASA, and so forth.
Yes.
That certainly can be applied in academia.
Yeah, great. Thank you. What do you see as the most promising near-term societal applications of quantum computing?
That's a great question. That's the question of the $5 million, in fact. I just say that because Google is giving a prize it's sponsoring a competition for people to come up with real world applications of quantum.
Oh, and so you don't want to give yours away.
Well, I mean, we participated in that competition. Oh. We're still up there. I don't know whether we're gonna win. I hope so. but I mean, here's my take, right? I believe that these quantum devices, right? These quantum computers, they allow us to process information according to certain laws that describe very particular systems, very particular physical systems. Cold, isolated, tiny pieces of matter behave according to quantum mechanics. Now, who cares about describing such systems, right? And you can make the case that the space where you are operating looks similar to optimization search spaces, so that's why there is a lot of interest in optimization. You can make the claim that these probability distributions are complicated and that relates to machine learning. My personal take is that if there is a community that cares about how very tiny things behave, are chemists and chemical engineers. We care about molecules. We do worry about how two molecules interact with each other and produce another one. Right. So all this to say, like my opinion and a few folks in the field agree, is that the first applications that we will see making a big difference in society using quantum computers are going to be in chemistry. Okay. In predicting these molecular systems.
And that's what you submitted for the prize? Something similar?
Oh my!
Or no, you don't. You don't have to go.
I actually can tell you. No, we submitted something related to healthcare and to machine learning. Okay. So for the Informs folks, you might have seen a couple of my talks about quantum federated learning. So that was our submission. Oh. We found this corner case in machine learning where size is not what matters, where currently quantum computers cannot compete in terms of size, but it's more about we were using it to help us with privacy issues, with how do you make sure that messages that you send cannot be hacked. Okay. And that this can be useful whenever you have many agents doing machine learning at the same time and you don't want somebody eavesdropping.
Yes, of course. So you related that to healthcare industry?
But it could apply. There are various applications of this distributed or federated machine learning. Some in telecommunications. We identified a nice application in healthcare because you wouldn't like your medical data to be shared openly, right?
Certainly not.
At the same time, if we are to build these predictive models, we would like to make use, the more data we have access to, the better. So how do you handle this trade-off between how much data can be shared and how much information can I extract?
Right.
So that's at the end of the day, we were doing predictions, I don't know, from x-rays, whether people had tuberculosis or MRI scans or CT scans, and we had some very compelling results. So that's our ticket.
Awesome.
There.
Congrats / good luck. When you need to step away from all things quantum, tell us how you recharge.
I recently got married.
Oh,
That's certainly keeping me very happy nowadays. We do have a big Bernese mountain dog. So he, well, actually your question is what keeps you energized, but he keeps me tired. So, but I do enjoy spending time with that. And then, well, just enjoying time in family.
That's great. Well, we're going to talk about quantum some more, though, now.
Sure.
So you are part of the Informs Quantum Computing and Operations Research Committee. Maybe began as ad hoc committee, now as a full-fledged committee. I don't remember the process there, but tell us how you see OR and analytics evolving in the quantum era, and then what role you think the Informs community should play in educating and preparing practitioners for this new frontier.
Of course, like David Hunt, who serves as the president of Informs, decided to create this ad hoc committee. And I couldn't agree more with that decision, because there is a lack of trained workforce to basically carry over what we call the second quantum revolution. Like, for the recent statistics I was reading around, is that for every 3 job postings of quantum computing, quantum communications, quantum sensing relating jobs, there is only 1 applicant.
Oh.
So how are we going to fill this gap? Certainly there are programs arising nationwide on training folks from scratch into quantum information sciences. But we cannot wait that long, right? So how, and then we start looking for folks that have already like a very solid basis that can quickly become like those that take these positions. And certainly if you start after not too long talking to people in quantum and in optimization, quantum and OR, quantum and chemical engineering or process systems engineering, you start realizing there are many common threads. There are many common things that we, and I say we now with my optimizer hat on, know that can already like bring value to this field. So I think certainly how can we contribute? I think that our training, it has already given us enough tools to not only hold up the conversation, but actually push the boundary of what is possible nowadays. And well, if it's not us, then who, right? I think that other disciplines are also realizing this, and they might be realizing that their training was not as well fit. So it's okay, right? I mean, I think that it's a good mission. It's a noble mission, and it has grown already organically, in a sense. The community has been already talking about quantum here and there. The fact that this committee exists only helped us coordinate this. So in the recent annual meeting and Computing Society meeting and Optimization Society meeting, we have just organized all these efforts, and once things are organized, they flourish, right? So that's I think what we can bring to the table, what this committee has been doing. Well, you're more than familiar with ORMS today, so we've written a couple notes there on like giving more details on how this community can contribute. But I fully stand with those thoughts. I think that we have so much to bring to the table. It's out there for us to grab.
Yeah, we're happy that you volunteered or were voluntold to join that committee. Besides that, what's your favorite Informs member benefit? Why? What's kept you here for 15-ish years? Right?
Well, I mean, I certainly have a lot of friends here in this community, right? And members, students, mentees. So being able to be part of this community to me is the greatest benefit that it comes with the membership.
Yeah.
Now, if we're talking about more material things, I like that subscription to the Informs Optimization Society and Computing Society divisions, which are where I best fit within Informs.
Networking, communities,
exactly,
all of it. Great.
Exactly.
Okay, this one you might need to think about a minute.
Please.
If you could invite any 3 scientists or researchers or thinkers, living or dead, to a dinner party to debate the future of computing, who would make your guest list?
I think I have a roster.
Okay.
So here we go.
Who's at the table?
So first, John von Neumann.
Okay.
So the architect of basically the way that computers, right, and the way that we think how to compute. Fun fact: he's a chemical engineer.
Oh.
Was a chemical engineer.
Fun fact. Huh.
So.
A little bit of hero of yours, then, huh?
Yeah, certainly, right? I mean, certainly he would be on that table. Then there is this well-known American physicist called Richard Feynman.
Okay.
Anyone that has studied physics has gone through the Feynman lectures of basically everything in physics.
Okay.
He sort of motivated the whole development of quantum computing. He was extremely creative, participated in the Manhattan Project, but then in the 80s he gave this talk and he had this very celebrated phrase that said that nature is quantum mechanical. So if you want to simulate nature, our computers better be quantum mechanical. Like not having quantum computers is just ignoring a big chunk of nature. So he'll certainly have some fun things to say at the dinner table. And then last but not least, I think I would bring one of the Nobel Prize winners of physics in 2025, John Martinez.
Okay.
His research group at UC Santa Barbara was later absorbed by Google and led to them having all these quantum supremacy, quantum advantage papers in the most recent years. He decided to leave Google, create his own company. They were doing pretty well. So I would like to ask him a few questions about that. So yeah,
sounds like it would
these 3 gentlemen would be a fun,
very lively discussion.
Oh,
maybe your wife would want to skip that one. You think she'd want to?
She has a PhD in chemical engineering as well. So I mean, she can out-science all of us.
So she'll be there too.
Yeah,
okay,
that for sure.
Great. My last question for you is, I don't know, this one might be your hardest question. If you hadn't pursued chemical engineering and optimization, what completely different career might you have chosen?
Oh, okay. It's only hard because you added the completely different. I usually say if I hadn't done chemical engineering and physics, it would have been math and computer science.
Okay, yeah.
Right? That doesn't count, right? I mean,
Too close.
Too close. And this has been sort of a common thread among a few chemical engineers I've asked. I don't know why, like, frustrated architects become chemical engineers, but we all have like this kind of inclination to architecture. So that'd be my
okay. That'd be fun.
Yeah, for sure.
Awesome. Well, thank you.
Thank you. Thank you so much.
Thank you all for watching. Happy New Year. If you have a resolution you want to share with us, put it in the comments below. Please like and subscribe to our Informs YouTube channel so you don't miss any of our great content like my chat with David today.